All right, number 3, compare two photon transitions below, 3 to 2 versus 3 to 4. Which is absorption and which is emission? So remember, on all of these electron shell types, the level 1 is going to be whichever one is closest to the nucleus, and then you're going to go 2, 3, 4 out, right? Just like in this one, you're going to go 1 and then 2, 3, 4 out. Doesn't matter if you go left, right, up, down. Remember that absorption is going to a higher energy level. So you'll notice that in this picture, energy is coming in and it's being absorbed. It's going to a higher energy. It's going from 2 to 3. So absorption is a higher number, or a higher shell, or a higher level. Emission is dropping down. So if you are at 3 and you drop down to 2, that is emission. So that is a lower level, right? Or a lower shell. So in both of these cases, we are transitioning between 2 to 3 or 3 to 2, but the 2 to 3 that is here, right? This guy here is absorption because it's going to a higher level. This guy here is emission because it's going to a lower level. So let's examine these two numbers here. You've got 3 to 2 and you've got 3 to 4. They're both starting at 3, but 3 to 2 is going to a lower level, so that's emission. 3 to 4 is going to a higher level, so that's absorption. So this guy here is emission, this guy here is absorption. Now question 2 says they both change in energy level of only one value, 3 to 2 versus 3 to 4. But will the energy content of these jumps be the same? And if different, which one is more and why? Well, you got to remember that these energy levels get closer and closer to each other the further and further out from the nucleus that you go. So you'll notice that the difference between 1 and 2 is the biggest energy jump. That's a big energy jump. And then the difference between 2 and 3 is smaller. The difference between 3 and 4 is even smaller. And then by the time you get 4 to 5 and 5 to 6 and so forth, they are overlapping each other so much it's tough to tell any difference at all. So, consequently, the closer you are to the nucleus, the bigger the energy jump is. So what we've got here is the following. According to this, we are going to go from 3 to 2, it says. So one of our jumps is from 3 down to 2. And then the other one of our jumps is 3 up to 4. So this is 3 down to 2, and this is 3 up to 4. Clearly, those are not the same amount of energy, and based upon the distances shown in this graph, 3 to 2 is a bigger jump, so this is more energy than this guy here. That's going to be less energy for that guy.